In this example, I'd like to just get a little bit more practice finding vertical asymptotes and then evaluating limits at those vertical asymptotes. So here I want to find all the vertical asymptotes of f of x equals x cubed minus 10x squared plus 16x, all divided by x squared plus 8x. And once I have those vertical asymptotes, we'll find the one and two-sided limits at those x values. So if you're looking for vertical asymptotes, my suggestion is always to factor. It's just going to make the rest of your work a lot easier. It's going to break it down into smaller, easier to manage pieces. So let's go ahead and factor this. F of x. I have a common factor of x in both my numerator and my denominator, so let's get rid of that. That'll leave me with x squared minus 10x plus 16 in my numerator. And then in my denominator, I'll have x times x plus 8. Now, if you want to, you can go ahead and take that factor out and cancel it. Remember, though, that this is not a vertical asymptote. If you have a common factor that you cancel, we would take that common factor, in this case x, set it equal to 0 and solve that equation. So in this case, it's just x equals 0. But rather than a vertical asymptote there, I actually have a hole in my graph, which is a lot different than a vertical asymptote. So just to highlight the difference between those two. In this case here, we can still factor this a little bit more. So I'm going to factor my numerator. I will have x minus 2 times x minus 8 divided by x plus 8. And again, you'd cancel any common factors that you can. In this case, we cannot. There's nothing we can do. So we said in the last video that vertical asymptotes occur when the denominator, so when x plus 8 is equal to 0, but the numerator is not. So we're going to take that denominator, x plus 8, set it equal to 0 and solve. So here I have x equals negative 8, which this tells me that this is the location of a vertical asymptote. So I know that I have a vertical asymptote at x equals negative 8. So there's the first part of my problem. I found where I have my vertical asymptote. I only have one. It's at x equals negative 8. So now that I've identified that vertical asymptote, we want to look at the one and two-sided limits. We'll start with the one-sided limits, and then the two-sided limit will follow naturally. We're going to find the one-sided limits at x equals negative 8. So let's do that in a different color down here. Let's start with the left-hand limit as x approaches negative 8 of... Now you could take that whole function, right? You could say x cubed minus 10x squared, blah, blah, blah. But I know it's going to be easier if I just use that factored form. So I'm actually just going to use this version right here. I'm going to use x minus 2 times x minus 8 divided by x plus 8. And that'll at least give me the information I need about the behavior close to negative 8. So let's start with the left-hand limit. So let's look on the left-hand side here. So I've already determined here that this is a vertical asymptote. So I know that this left-hand limit, because it's a rational function, is either going to be positive infinity or negative infinity. I just need to figure out which one. So again, I'm going to use the same method that I've been using all along here. Maybe let's use a different color. Let's do this part in red. So I'm going to choose a number that's close to negative 8 on the left-hand side. And just be careful that we don't get mixed up when we're working with negative numbers here. So here I've got negative 8. If I want a number on the left-hand side, you might think about, say, negative 8.1. So I'm going to pick negative 8.1 and plug that into my function. Just determine, do I have a positive number or do I have a negative number? So I'll have negative 8.1 minus 2 times negative 8.1 minus 8 divided by negative 8.1 plus 8. So here, negative 8.1 minus 2, that's going to be a negative number. Negative 8.1 minus 8, that is also a negative number. Divided by negative 8.1 plus 8, that is also a negative number. So in my numerator, negative times negative gives me a positive. negative from the denominator just carries down. And then positive divided by a negative, this is going to approach a negative number, which means that this limit should be negative infinity. So I have the left-hand limit for right now. So I have the left-hand limit. I'm now going to do the same thing for the right-handed limit as well. So for the right-sided limit, limit as x approaches negative 8 from the right-hand side, I've got x minus 2 times x minus 8, all divided by x plus 8. And here again, I need a number on the right-hand side. Refer to your number line up here if you need to. If I need a number on the left-hand side, right, I'm thinking about a number between negative 8 and negative 7. So I might pick, say, x equals negative 7.9 and plug that in. So negative 7.9 minus 2 times negative 7.9 minus 8 divided by negative 7.9 plus 8. My numerator, negative minus a negative is a negative. Be careful with this guy here. We might get confused with negative 7.5 and negative 8, but I just have a negative number here minus another negative, so it just gives me a bigger negative number. In my denominator, negative 7.9 plus 8, that's a positive. So here in this case, I have a positive divided by a positive, which means I'll end up with a positive number. So that means that the right-hand limit, this must approach positive infinity then in this case. So I have the left-hand limit, I have the right-hand limit. So then when it comes time to talk about the two-sided limit, the limit as x approaches negative 8 of f of x here, well, they're not the same, so the two-sided limit does not exist then.